Hi, this is my demo 6, and today I'll be showing you 7C, 7D, 7E, arithmetic circuits, routing circuits, and hierarchy. And I'll be doing the adding, the mux, and then I'll be also doing the hierarchy to show you. And I chose to do this because of this quiz. I use it for as a reference, and I wired it, and I will explain it. So with that, we can go along with the Logisim. As you can see here, this is my full adder, which is just 1 bit, which is 1 bit is 1 0. So as you can see here, 1A is 1, it's going to give us 1. 1B is 1, it's going to give us 1. And since this is 1 bit, we are going to need a carry out if we want to do 1 plus 1, because that gives us 2, and that will be displayed in the carry out. And we can also do 1 plus 1 from this carry in, which gives us 3, 1, 1. And with that, you can see that's just our adder. And with this, we can go on and go to adder 3. So this is 7C. So as you can see here, I did some addition, but as you can see here, we have a 3-bit adder. Our Cin is ground because it has to be 0 to display the C out, and this C out gets fed into each of the adders. When it gets to the final adder, it shoots it out and displays it. So as you can see here, all we did was just drag 3 of the 4 adders and created more variables, more inputs, so it can be a 3-bit. So here you can see we can do some arithmetic. We can do 1 0 1, that gives us 5, as you can see here. We could do 5 plus 1, which gives us 6 0 1 1 0. Or we can do 5 plus 5, which gives us 10, as you can see here. And then if we really want, we could do 5 plus 6, which gives us 11, as you can see here. 8, 10, 11. So as you can see here, this full adder works. So our 7C is finished for our adder. And then here we go to the mux. And the mux is pretty much a shifter, which pretty much relies on this switch. Let's go into 2 different modes. So as you can see here, we have D1. It doesn't display anything because of this switch. So it's focusing on D0 and it's displaying D0. But when I flip the switch, it will show D1 as the output. And if I make D01 and D11, it's just still going to display D1. How? If I turn this on, you can still see it's just focusing on D1. The moment I turn this switch off, it displays D0. And you may be asking yourself why I included Cin and Cout. The reason I did this is I can show you later on in the video. It's just for inputs and outputs. So here is our next. It's our 3-bit mux. So with this, we pretty much just had included 3 muxes from mux 2 to 1. So we can make it 3 bits. And as you can see here, the Cin, again, is just for an input and an output. It has no purpose for these until the final multi 3-bit. But as you can see here, the Cin is getting fed through each of the muxes, and it's getting displayed out. And I'll show you at the end to see the full purpose of it. But for this one, you can see here that we have 3 bits. So like we said, D1 and D0. So when select is on, it's going to focus solely on B. But when it's off, it's going to focus solely on A, as you can see here. So if I make this 1 1 1, it's still going to focus on A because of the select switch. The moment I select 1, it'll jump straight to B. As you can see here, that's what it did. So you can see here that this mux works. So yeah, and then now we can go on to our last 7E, which is this multi 3-bit. So here you can see I kind of have an output. I kind of tested it. Here, this is our hierarchy. So here we added the adder and our mux 3-bit 2-to-1. So this is our 3-bit adder and our 3-bit mux. So the adder lets us add 3 bits together, and then our mux lets us choose if we want to choose display the output or just display 000, which is our ground, as you can see here. So if we do select 1 and we do all ones, no matter what we do, it's going to just display 000 because of this select switch. The moment we turn the select switch off and we do 1 plus 1, which gives us 2, it starts performing the arithmetic. And the reason I included that cin in the muxes was just so the C out can be transferred into the mux and displayed. Because if I just took it straight from the C out and displayed it into this LED light, no matter if I hit select 1, this LED light will turn on if the answer is bigger than 7 bits or bigger than 3 bits. So the reason I included this C in and C out from these muxes was so when we do that and we select 1, it will not display the LED. So the moment I hit select switch off, it will display the answer. So 7 plus 7 is 14, 8 plus 4 is 12, plus 2 is 14. And then we can do 4 plus 4, which gives us only 8. We can do 5 plus 4, which gives us 9. 5 plus 5, which gives us 10. And we can do something like 5 plus or 6 plus 3, which gives us 9. So as you can see here, this works. And the moment I hit the select switch, all zeros, no matter what. So this is a very fascinating, very cool way to see hierarchy. So we went from the adder to the mux to the hierarchy, which includes everything in here. And I really showed how we can include the C out into this hierarchy, because if we just had C out right here, we wouldn't display it because of this C out would always be 1 if this equation was higher than 3 bits. But yeah, this is the end of my demo. I